Hello future engineers, subscribers, viewers, and students. There is another video in calculus, particularly on differentiation of functions. So we have here first derivative, second derivative, and third derivative of functions. And I consider them as beautiful problems in calculus. So problem 1. If x to the n y to the m equals quantity x plus y to the n plus 1, find dy dx. So this is an implicit function. We have derivative of product. And in the right side, we use power formula. So x to the n times m y to the n minus 1 dy dx or y prime. So x to the n times quantity m y to the n minus 1 y prime plus second y to the n derivative of first n x to the n minus 1 times 1 equals quantity n plus m then times quantity x plus y to the n plus m minus 1 then derivative inside, which is 1 plus y prime. We then simplify this into mx to the n y to the m over y times y prime. Then this one n x to the n o n x to the n y to the m over x equals quantity n plus m x plus y to the n plus m over x plus y times quantity 1 plus y prime. We then factor out for these two terms common x to the n y to the m. Then times quantity my prime over y plus n over x equals, we just write the right side as is. Then simplifying further, and take note that x to the n, y to the m equals quantity x plus y to the n plus 1. We can cancel this. They are equal. And the LCD here is xy. So we have mx y prime plus ny over xy equals n plus m quantity times 1 plus y prime over x plus y. We then cross multiply. We have mx y prime times x plus y plus ny quantity times x plus y equals n plus m times xy quantity 1 plus y prime. We distribute, so mx square y prime plus mxy y prime plus nxy plus ny square equals n. We distribute xy into these quantities in the parentheses, nxy plus mxy times quantity 1 plus y prime. We then write this as is, then distribute the right side, simplify the right side. So the right side would be nxy plus nxy plus nxy prime plus mxy plus mxy y prime. We then cancel like terms like mxy y prime and nxy. So here mx square y prime and we have nxy y prime. We factor out y prime as common, then we have y prime quantity mx square minus nxy. And the right side, mxy minus ny square. For these quantities in parentheses, x is common, so we have xy prime quantity mx minus ny. Then in the right side, y is common, quantity y times quantity mx minus ny. We then cancel mx minus ny, so y prime x equals y, and write the final answer as dy dx, which is this y prime equals y over x. We then proceed to the second problem. If x cubed plus y cubed equals 1, find the second derivative of y double prime. So again, we differentiate this by implicit differentiation technique. So 3x squared plus 3y squared y prime equals 0. So that's the given. Derivative 3x squared plus 3y squared y prime equals 0. We divide everything by 3, so this reduces to x squared plus y squared y prime equals 0, for which y prime is negative x squared over y squared. We differentiate this further into 2x, then we have derivative of product y squared, derivative of y prime y double prime, plus y prime, derivative of y squared 2y y prime. So that's the derivative. We divide everything by 2, so we have x plus y squared y double prime over 2, then plus y double prime square equals 0. We replace y prime by negative x squared over y squared into the third term. So x plus y squared y double prime over 2 plus y times quantity negative x squared over y squared quantity square equals 0. We then simplify this third term into x to the fourth over y cubed, because we cancel y to the 1. So x plus y squared y double prime over 2, then plus x to the fourth over y cubed equals 0. Multiply everything by y cubed, so we have xy cubed plus y to the fifth y double prime over 2 plus x to the fourth equals 0. Then for the first and last terms, x is common, then we write this as x, quantity y cubed plus x cubed, plus y to the fifth y double prime over 2 equals 0. We note that x cubed plus y cubed plus x cubed is 1. We replace this by 1. So that reduces to x plus y squared y double prime over 2 equals 0. Finally, we get y double prime equals negative x times 2, so negative 2x over y to the fifth. So that's the answer for that problem. Then problem 3, if y equals x squared plus 4 over x squared, find the third derivative of y at x equals 2. We write this into x squared over x squared, which is 1, plus 4 over x squared, which is 4x to the negative 2. So first derivative is negative 8x to the negative 3. Second derivative is negative 8 times negative 3, so 24x to the negative 4. Then finally, third derivative is 24 times negative 4, negative 96x to the negative 5. We write this as negative 96 over x to the fifth, and we replace x equals 2. So negative 96 over 2 to the fifth is equal to negative 3. So that's it for this video. I hope that you were able to follow the explanations and the solutions.